Hello guys, today we're going to solve this question. The question says if a variable takes value ar square, ar power n minus 1, each with frequency unity shows that so that am multiplied by gm is equals to, this is small mistake, am multiplied by sm. Am multiplied by sm is equal to gm square. Also prove that a is greater than g is greater than h unless n is equal to 1 where g is equal to 1. Okay? A means arithmetic mean, g means geometric mean, h means harmonic mean. So am is am and a and they are derivative, they are same. Okay. Okay. If a variable takes value a comma ar comma ar square and this continuing ar and so on is with frequency unity, then we can write arithmetic mean a is equal to summation ex by m. Is the unity, so we don't need to write f. Okay. So we can write a is equal to summation x means a plus ar square. It means the total sum. Okay. So that is a plus ar plus the terms we are given. Okay. These are the terms we are given. So by n. Okay. So from this we can write like a by n. We will take a common. Okay, we will take a common. So a plus a plus a plus a will take a common and 1 by n to one side, and the remaining will be 1. 1 plus r squared plus going on, and this will be r power n minus 1. Okay, clear? So I hope you're clear up to here. And a is equals to a by n, and this will be the sum. This you are looking. This is the sum of geometric series. Okay, so the sum of geometric series, if you divide the second term by first term, you will get same thing as if you divide by third term, divide third term by second term. Okay, and this is geometric series. Okay, and the sum of geometric series, the formula for sum of geometric series is 1 minus r power n by 1 minus r if r is less than 1. Okay, you can write anything, like I would write 1 minus r power n by 1 minus r. Okay, you can also write r power n minus 1 by r minus 1, taking negative common and cancelling out negative terms. Okay, so this both will be same thing, doesn't matter. Okay, so now I write this thing, and now I leave it here, number 1 equation. Okay, so now another thing is g means geometric mean, which will be equals to n times the given terms like ar square and ar n minus 1. Okay, it's the formula of geometric mean. Okay, so g means this, and g will be equals to n times a power n. How many are here? A 1, and a, if we just apply the rule of indices, then a power 1 plus 1 plus 1 plus 1 plus 1, how many ones there are? N. So sorry, the n ones, so we can write a power n, and the remaining term will be r squared going on to r n minus 1. Okay, so g is equals to a power n, so we can separate like this. Okay, and we can separate this also, r into r square and going r into n minus 1. Okay, so g is equals to, and this will be equals to a power n into 1 by n. You know that it is our rule of indices. I hope you know the rule of indices, so you can apply here. And r into r square is going to r n minus 1, so we can write into 1 by n. Okay, just like the square of thing, like a square is equal to b, then we can write a is equal to b power b root means 1 by 2. So we apply this thing like here. So applying this thing here, we will get this, will reach up to this term. Okay, so again now g is equals to n and get cancel out, and a power 1 is a, so r, we'll take r common here. Sorry, we will take r, and we'll apply the r power 1, r power 2. Okay, it is 2 and going up to n minus 1, so we can write r power 1 plus 2 plus rule of indices. Okay, this is also rule of indices, n minus 1 into 1 by n. Okay, so now g is equals to a r, and this is sum of natural number of series. Okay, remember the sum of natural number of series, what we know is that for sum 1 comma 2 comma 3, and for some of these things up to n, we write n into n plus 1 by 2, but we are given it here is 1 2. Okay, 3, and going to n minus 1, not to n. Okay, we have given n minus 1. Okay, so for this, what we have to write is here, and the last term is n, so we write here n and add 1 to the n. Okay, so here the last term is n minus 1, so we'll write n minus 1, and here we had added 1, so we will add 1 to this last term, so adding 1 will be equal to n only. and divided by 2 is divided by 2. Okay, so what we got is n into n minus 1 by 2, and that will be the sum. So I write here directly n into n minus 1 by 2 into 1 by n as it is. Okay, so 1 n got cancelled. Okay, and g is equals to ar, g is equal to ar and n minus 1 by 2. Okay, we got another geometric mean. Okay, so now we will now write yes. I hope you are writing with this so that you are understanding it well enough. Arithmetic mean formula for arithmetic mean is n times total number of observations upon 1 by a plus 1 by ar plus 1 by ar square. Okay, so this goes on to 1 by ar power n minus 1. And this is formula. Okay, you have to memorize the formula for harmonic, geometric, and arithmetic mean. Okay, so arithmetic mean is equals to what I have to do is take common a. Okay, 1 by a should be common, so we'll invert and make a n. Okay, a will go to upper side. Okay, so that upon, and the remaining will be 1 plus 1 by r plus 1 by r square plus, and that goes into 1 by r power n minus 1. Okay, so h will be equals to a n by, so we will again apply the same rule as we had applied in arithmetic mean, that the sum of the geometric series is now we have put that r is 1 by r. Okay, so formula was like that, sum is equals to uh, sum is equals to r power n minus 1 by r minus 1 or 1 minus r by 1 minus r power n by 1 minus r. Okay, so I now write r power n minus 1 by r minus 1. Okay, now with this now we have to take r is 1 by r. Okay, because if you divide this by this or this by this, you will get 1 by r. Okay, so now our r is 1 by r, so applying this formula, what we'll get is 1 by r. Okay, that will be 1 by r power n. R is 1 by r and power n and minus 1 by 1 by r minus 1. Okay, just remember r is 1 by r and apply the formula. H is equal to a n by, and take LCM, 1 power n is 1 minus r power n by r power n. Okay, the n power goes to here, and when we take LCM, we will get 1 minus r power n by r power n, and so we will divide by this thing also, 1 minus r by r. Okay, I hope you are understanding it. So h is equals to a n by 1 by r power n by r power n, and we have to do this thing. Okay, we'll take this and invert this. Okay, so we'll get r by 1 minus r, and this will be equals to if we just do multiply and divide formula, like r when it comes downward, it will become r n minus 1. You know that thing, and it is on here, so it will go up. Okay, you know that thing also. So it's equal to a n 1 minus r. This 1 minus r also goes to upper side, and the remaining here r n minus 1 also. R n minus 1 is r comes down. Okay, so r n minus 1 will be on upper side of the fraction, which is now 1 minus r power n. Okay, the remaining term is this, so we'll get this thing. Okay, now it's simple. If you calculate thing, then you can get this up to here. Okay, now as we have find harmonic mean also, geometric and arithmetic mean also. So now am multiplied by gm, we'll just put the value. We know the value of a, as we already made here, 1 by r power n by 1 by r multiplied by n. Just now this is yes. Okay, I do a lot of mistakes, and again a 1 by r 1 minus r by r power r for n minus 1 here, and 1 by r power n here. Okay, this is the formula for harmonic mean, this is the formula for arithmetic mean, which we did just right now. Okay, so if we just is a little low brightness. Okay, we have to increase the brightness. Now it is okay. Now this will be equals to 1 by r. Then this cancel, this cancel, this cancel, this cancel, this cancel. The remaining will be a square r n minus 1. We can write this is a r n minus 1 by 2 whole square. Okay, is 2 to cancel out, so 2 goes to the power of a. So this is the formula of gm. So we can write gm square. Okay, so we already proved one thing, am cos hm is equal to gm square. Okay, this is the formula, and now we will prove that arithmetic mean will be greater than geometric mean will be greater than harmonic mean, unless n is equal to 1 when they all will be equal. Okay, so for that Now for first we'll write a is greater than g. For a is greater than g, if we'll put the formula a by n. Formula for a is a by n 1 minus r power n. Okay, 1 minus r, which should be greater than a r n minus 1 by 2. Okay, so this should be if this is if this is true, then if this should this also be true. Okay, so we're going from backward. So we're solving it from backward. Okay, so a will cancel out. So here remaining will be 1 by n, and here if we just open this, okay, if we open this like we have opened, what we'll get is 1, sorry, what we'll get is 1 plus r square plus going on to r n minus 1. Okay, this is what we'll get when we'll open this. Okay, uh, in last derivation we derive from this to this. Okay, so you can watch and just we just write this going backward. Okay, so this will be greater than this. What is this? So this is n times root over r into r x square into r cube going r n minus 1. This is also same thing, just you have to just apply the formula as we did right now when while deriving thing. Okay, you can just watch it from there. We're going backward step. So if this is true, then from this relation we can say that this relation is true. So you can say the nth root of something and something upon n. This will be greater. Okay, just like x upon n should be greater than nth root of x. Okay, if we just put the value of x till n, let's say that if you put the value of x is 16 and n is 2. Okay, so it will be like 16 upon 2. That will be 8 on this side, and here n is 2 and x is 16. So 2 16 means square root of 16 is 4. So 4 will be here. So you get, and this will be always bigger, or this will always be equal. Okay, equal or bigger. Okay, so this is true. So from this you can do experiments yourself, and you can just write this relation is true, and you do same thing for g is greater than h. And we will put the formula arn minus 1 by 2 where then a r sorry an. Okay, formula for r minus is an rn minus 1 and 1 minus r by 1 minus r power n. Here also we'll cut down a, and we'll find r n minus 1 by 2 is greater than n. Okay, I'll write it again. We wrote here like a r n minus 1 by 2 is greater than formula for gm. Formula for an is a n r n minus 1 1 minus r, the 1 minus r power n. Okay, a got cancelled out, so go ahead and write 1 minus r if this is true. If g is greater than yes, then this should be greater than this. Okay, and this 1 by r power n 1 minus r should be greater than n into r n minus 1 by r n minus 1 by 2. Okay, well this term goes this side, this term goes this side. It's a simple calculation you can do yourself. There is not a hard part. And if this is true, and this should be also true, like 1 minus r power n by 1 minus r, taking n to this side, that should be greater than r power n minus 1, and taking this to upper side with the rule of indices n minus n minus 1 by 2. Okay, here will be bracket, and if this is true, then if 1 minus r power n by 1 minus r, okay, whole divided by n, this same thing. Okay, it's the same thing, just don't get confused so much. R power n minus 1 by 2, if you calculate this, you get this. Okay, so it's the same thing. If we open this formula, we'll get 1 plus r square plus same going r power n minus 1 by n, which will be greater than this. And this is the same thing that I just make you view right now. That is nth root of r square going r cube going to r n minus 1. So again, this is the same thing that I already told you by doing experiment, that this will be greater always and this will be true, which will be true, which is always true. Okay, so we proved. So a is greater than g is greater than yes, we proved this. Okay, so now for the part that if what we have given, what our question said was we have to prove a is greater than g is greater than yes unless n is equal to n when a is equal to g is equal to h is equal to 1. Okay, so for this one, when our n is equal to 1, just we have to put in formula. What is our formula for a? it's a by n, 1 minus r power n by 1 minus r. And when n is equal to 1, that is a 1 minus r by 1 minus r, that will be equal to a. Okay, and formula for gm would be a r n minus 1 by 2, and when n is equal to 1, that will be a into r power 1 minus 1 by 2, that is 1 minus 1 is 0, and 0 by 2 is 0, so r power 0 is equal to 1, so that will be a. Formula for AHM is equals to a n r for n minus 1 by 1 minus is multiplied by 1 minus r, so divided by 1 minus r power n. Okay, when n is equal to 1, remember this cancel out, and n is equal to 1 minus 1 is r power 0, which will be equal to 1. Okay, so here, so here n1 is here 1. Okay, I can make it like a into n is 1, so a and r power n minus 1 is 0. Okay, so here 1 minus r and divided by 1 minus r is n is equal to 1, so that will be again equal to s. So a is equal to z is equal to s is equal to a. We prove this thing. Okay, when a is 1, n is equal to 1. This much.